Hello everyone, I am Aditya Das and I am here with my team Quantum Quirks and we are participating in the upcoming Smart India Hackathon, and the problem statement that we have chosen is maximizing section throughput using AI powered precise train traffic control. So let's get started with our topic. As we know that the train traffic system mostly run on manual way. There are manual inputs and manual decision making. So the core idea behind our presentation, or the idea of for this topic, is to provide some automation to it, such that machines can take the decisions and humans can implement it. So let's look at what the proposed solution is for this model. First, greedy conflict resolution would be done, which will detect clash and allocate blocks instantly in real time. Dynamic waitlist handling, delayed trains are requeued without halting the overall flow. Throughput maximization will be done. Delay minimization, which is very important because we will minimize the delay by using a scoring system, which is equal to priority into wait plus delay. Data-driven operations, it uses live GPS feeds, signal states, and block occupancy data. AI-enhanced optimization, the core engine uses greedy heuristic, but when it will be scaled to and applied in the real world, then ML models will be implemented for delay prediction and reinforcement learning agents for adaptive scheduling. Scalable intelligence and human in the loop safety, which is very important because it is not fully automated, because railway primarily focuses on safety rather than optimality. So whenever any case of failure or edge cases occur, the system will seamlessly shift back to human dispatchers for safety and reliability. And finally, the basic working MVP to demonstrate the system is provided here. And in the right, we can see the flow chart. So just take a good look at it. Whatever I have said, that is only just written here. We'll just move on to the next slide. For the technical approach, we'll be using the Python because AI implementation is most suitable with this language. There will be several libraries and frameworks we'll be using: Pandas and NumPy for train schedule and data handling, NetworkX for graph-based railway section representation. Because in our system, we are representing the whole railway network as graph, where the nodes represent stations and the edges represent the blocks. Matplotlib or C1 for KPI and timetable visualization, SymPy for discrete event simulation, Scikit-learn for ML models, TensorFlow or PyTorch, OpenAI Gym or Early for reinforcement learning, Django Flask plus React for the final dashboard. There is a front end. Prototype environment, local simulation would be done for now in our prototype, but in the actual case, real world software would be there. And integration tools for APIs for GPS face, IoT sensors, etc. would be there. Methodology, core scheduling would be done by greedy heuristic to solve immediate conflict. Then dynamic waitlist handling would be done. After that, throughput maximization will be done. Delay minimization would be done, just like I said in the previous slide. AI enhanced layers will be there. Will be 4 layers actually: prediction layer, optimization layer, simulation layer, and adaptive prioritization. Live KPI tracking. KPI means key performance indicators, which will show how good the system is working. Decision support dashboard will be there. It is absolutely scalable, and it is also future integration ready because we can plug and play with signaling systems, the Kavach safety system, TMS, and IoT feeds. Next, our prototype is not the prototype actually. The idea is completely feasible. It is technologically feasible. It has lightweight algorithms. It is existing system integration can be done, and viability, cost-effective throughput, automated safety enhancement, delay reduction, leverages existing data, gradual adoption, and supports modernization as well. It aligns with the Digital India initiative. Next, there will be several impacts and benefits with our idea. First of all, faster, reliable service would be done. Congestion would be reduced. Freight logistics would be improved. Operational safety will be enhanced, and coordination will also be improved. And benefits include social causes, economic, environmental, and as well as operational causes. So, and these are the research and references, which are mostly Indian Railways research papers on safety and signaling systems, tutorials on them, etc. Also, there are some case studies. So that's all from the presentation side. Just now we'll just shift back to the prototype. Yeah. So this is a sample output of our prototype that I've just run. So let us understand it. First of all, the real-time updates are being shown, which are actually at every timestamp what a particular train is being allocated, what block is being allocated. Here, like EXP101 represents an express train, which moves from block 0 to 1 from timestamp 1 to 3, And Freight 201, which is another train, it moves from node 4 to node 3 from time 1 to 2. At t equals to 03, local 301, which is another train, it has been waitlisted because in the priority order, at for now express 101 stays at the higher level than local 301, so it has been pushed to waitlist. First express 101 will be passed, and then the local 301 will be passed. This is how the whole real-time updates are being shown. These are the KPIs that I was just talking about. First of all, trains completed is 4, means 4 trains were able to reach the destination safely. For our prototype, we have taken 4 sample trains. Average terminal delay is 3 time units. We are not specifying any particular time unit for now. Utilization 0.242, which means at any point of time, average utilization of the track was 0.242. And conflict avoided is 4. 4 conflicts were avoided in this system. And so these are the timetables, planned versus actual, for all the 4 trains. As you can see, we'll just take an example to understand how the conflict resolution is taking place. So for express 101, at node when it at node 2, it is planned to arrive at 6. Also we can see for flight 201, it is planned to arrive at node 2 at 6 time units only. So these are clashing. So what we will do, as express 101 is up on the priority level, so we will just pass express 101 first and make flight 201 wait. So these are the planned arrivals, which are the actual timetables. And next, the actual arrival, we can see it is express 101 was delayed by 1 minute, and departure was done only 1 minute after, that is 0708. But for flight 201, we can see it was supposed to depart 1 minute later, but it departed 3 minutes later because we delayed it for train express 101 to pass. That is how our system is taking place. And like this, there are 4 conflicts in this scenario only. If you see the output very clearly, you can understand. And this was the first scenario. And then in the second scenario, there is maintenance on block 1 to 2 at time 6 to 9. Means at timestamp 6 to 9, there is a maintenance on block 1 to 2. That's why for at that time there are some trains which are delayed, like we can see in this in the actual arrival time of and departure time of these trains. And at the last scenario, which is scenario C, we are downgrading the express 101 priority. So express 101 is moved to second priority, and local 301 is moved above. So here 6 conflicts were avoided, and the system works in the same way that I just told. So this was all from our side. This is a very sample prototype, and in this prototype we have only used greedy heuristic, but this is the basic idea, and it can be scaled with the help of several ML and RL models while implementing in real life. Thank you very much.